Welcome everyone. The question number 14 is, in a circular loop of radius r, the current I enters at a point A and exits at a point B as shown in the figure. The value of the magnetic field at the center O of the loop, option A is mu naught I by r, option B is 0, option C is mu naught I by 2r, and option D is mu naught I by 4r. Okay. Now at first try to understand how many sections are there in this figure. Okay, so I current enters from here, so one section is there. Okay, that one section, this one section basically comprises of from infinity to A. Okay, there is two section, number two section is basically comprises that 1/4 of the circle, okay, from A to B. Number three section is basically comprises of this 3/4 of the circle from A to B, and number fourth section is comprises from B to infinity. Okay, so for four different section we have to calculate the magnetic field, and four different magnetic field we will get. Okay, so for the one section, that is which is the from infinity to A, and the point 2 where the magnetic field we have to find it out, that is on the extension of the infinity to A section. Okay, and we know that if the point of observation is on the extension of the current carrying conductor, okay, then the magnetic field is 0 here. Okay, since the magnitude is 0, we need not to think about the direction. Now if we think of the B2, okay, B2, for the B2 section, let us, we have to consider that if the I current enters from A, let us it divides into two different parts. Let us say this is the I1 part, and let us say this is the I2 part. Okay, this is the I2 part, and obviously we can say here capital I equal to I1 plus of I2. Okay, so here we can say for the B2 section, if we want to find it out what is the magnetic field here, for that purpose we can use one formula, that is if there is a theta arc. Okay, if there is a current carrying arc, and if you want to find the magnetic field at the point O, okay, what do you know? We know that if theta is the arc there, then the magnetic field at O due to this current carrying wire is mu naught I divided by 2r multiplied by theta by 2 pi. Okay, so for the B2 section, okay, it is pi by 2 on 90 degree, so that is mu naught I divided by 2r, and theta is pi by 2 here, divided by 2 pi. Okay, so B2 is here, and in which direction it is, and obviously if you apply the right hand thumb rule or any kind of rule to find it out the directions of the magnetic field, if the direction of the current flow is known, then at the point O the magnetic field is perpendicular downwards to that of the plane of the paper. So you can see it is downwards, you can see it is downwards. So this will become mu naught I 2r, okay, and pi by 2 divided by 2 pi, that becomes 1/4. Okay, so this becomes mu naught into I divided by 8r. Okay, and that is downwards. Now for the B3 section, okay, for the B3 section, okay, here the angle, if we think about the angle here, that the angle is here 3 pi by 2. Okay, so that is mu naught into I divided by 2r, 3 pi by 2 divided by 2 pi. So this will be what is the direction. Now if I know the direction of the current flow, if I want to know what is the direction of the magnetic field, and that is in the upwards direction. Okay, that is the upward direction. Okay, one thing I have forgotten there, the current is I2, and in the B2 case the current is I1. The current is I1, that is upward section. Okay, now that is mu naught I2 divided by 2R, and this becomes simply 3 by 4, and that is upwards. It is upwards. So we can say this is simply mu naught I divided by 8R upwards. Okay, upwards. So now what is B4? That is for the fourth one. Here also for the same reason the magnetic field is 0. That is the B2 infinity section is there. The current is flowing through the B2 infinity section, and the point O where we have to find it of the magnetic field, that is an extension of the B2 infinity section. So the magnetic field is 0 here. So we can say B4 is 0. Okay, so B1 and B4 does not protrudes to the resultant magnetic field, only B1 and B3 does. Okay, so if I want to write it down, what is BO? Okay, what is BO? Then the BO is the sum of B1, B2, B3 and B4. So but here the magnitude of the B3 is greater compared to that of the magnitude of the B1, B2. So we can say that is simply B3 minus of B2, and that is in which direction? That is in upward direction, upwards. So this is 3 mu naught I2 divided by 8R minus of mu naught I1 divided by 8R upwards. Okay, so mu naught by 8R we can take common. Okay, 3I2 minus of I1, but here I1 plus I2 is I. Okay, I1 plus I2 is I. Now if I try to understand from the common sense here, if the current is divided at the point A into two different parts, I1 and I2, in this particular case, if it's moving from A to B, the length of the conductor it have to pass through, and through the A3B section, the length of the conductor it have to pass through are different. Obviously, the resistance of the RA to B section, if I compare with the resistance of the RA3B section, okay, resistance of the RA1B section, we can say that is 1. Resistance of the RA3B section, we can say that is 3, because the length is almost 3 times. Okay, so we can assume that this I1 is capital I divided by 4 multiplied by 3. Most of the current passes through this because resistance is less. And in the I2 section, here I by 4 multiplied by 1. Okay, so if I put it there, so this will become mu naught divided by 8R. I2 is 3I by 4, and I1 is 3I by 4. Okay, so here the magnetic field is 0. Thank you all of you.